Mohon untuk para peserta to all participants, please pay very close attention because the event are going to begin. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning for all participants, both in this room and also on our YouTube channel. The Honorable Professor Masami Isoda from Tsukuba University, Japan. The Honorable Vice Dean of the Faculty of Teacher Training and Education, Universitas Ahmad Dahlan, Dr. Dodi Hartanto. And also the Honorable, the Head of the Mathematics Education Study Program, Waswatu Nasana, Master of Science. Lecturers of Universitas Ahmad Dahlan, distinguished guests, committees, students, and all participants. First of all, I would like to invite everyone to express our gratitude to Allah Subhanahu wa Ta'ala for His blessing and also for the opportunity so that today we can attend together the guest lecture with our amazing resource speaker, Professor Masami Isoda from Tsukuba University. Salawat and salam may always be directed to our Prophet Muhammad Sallallahu Alaihi Wasallam. And ladies and gentlemen, before I continue, let me introduce myself. My name is Aan Hendranto, and I will be the host and also moderator for the guest lecture today. And the topic is students' higher order thinking ability or students' higher order thinking skills in solving mathematics problem. Please let me read the list of activities for today. The first is opening. The second is singing national anthem Indonesia Raya. The third is speeches. And then main presentation from Professor Masami Isoda. And then we have discussion and then closing. To save the time and to keep on the schedule, let's open today's activity by saying Basmalah together. Bismillahirrahmanirrahim. Thank you. The next is singing national anthem Indonesia Raya. For that, to all participants, please stand up. Thank you. Please be seated. Ladies and gentlemen, the next agenda is a speech by the Dean of the Faculty of Teacher Training and Education, Dr. Dodi Hartanto. The floor is yours.
Thank you, Mr. Aan. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
warahmatullahi wabarakatuh.
The honorable speaker, Professor Masami Isoda, PhD from University of Tsukuba, Japan. Sensei Isoda, is that right, sir? Okay, Sensei, and also Ibu Uswatun Hasanah MSI, the head of Mathematics Education Study Program from Universitas Ahmad Dahlan. All the lecturer from Mathematics Education Study Program and all of the students. Alhamdulillahirabbil alamin, praise to Allah who has given us His blessing so that we can meet in this morning in a good condition, and also salawat and salam may also delivered to our Prophet Muhammad sallallahu alaihi wasallam, who has brought us from the dark age into bright days. Alhamdulillah, ladies and gentlemen, in this morning we can meet Sensei Isoda in good condition and good health. It is such an honor for me to speak on behalf of Faculty of Teacher Training and Education, and I will start by giving a warm welcome to all of you, and especially to express my appreciation to the speaker, Professor Masami Isoda, Sensei Isoda. We will learning a lot today. I would like to express my gratitude also to Ibu Uswatun Hasanah, the CMEO team, Mrs. Uki, and also I also wish to thank the committee who has organized this wonderful event. Today's seminar entitled Student Higher Education, Higher Order Thinking Skill in Solving Mathematics Problem. We can see that the pandemic has impact all of aspects in human life, including education. COVID-19 pandemic has driven radical change in university operation, teaching, education, and have explored alternative ways to operate in the COVID-19 impacted to new normal world. So I believe that it will become a new problem, a new paradigm, and also a lot of innovation, especially on mathematics education. Ladies and gentlemen, we all know that how education system is being changed with the advancement of emerging technology in post-pandemic education and post-pandemic situation. The future teacher, future learner, and also future classroom will be totally different. Teachers should train the student how to solve the problem in the future. Well, I do not want to make too much of your time. I hope that this event will help us to improve on our side in terms of student higher order thinking skill in solving mathematics problem. Now, I need to hand over the event to the MC. I would like to say once more, on behalf of the teacher training, on behalf of Faculty of the Teacher Training Education, welcome and have a wonderful event. Today, it is a great to meet you all, and finally, please apologize for all of my misconduct. Thank you very much, Sensei Isoda, for your coming in Ahmad Dahlan University, especially in Faculty of Teacher Training and Education. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to Dr. Dodi Hartanto for the welcoming speech and also for the introduction to our activity today. The next agenda is the main presentation by Professor Masami Isoda, but before that, we are going to take some photos for the documentation. So please, for Professor Masami Isoda to stand up in front of the tables to take photos for documentation. And also for all the lecturers from Mathematics Education Study Program, please come forward to take photos. Your picture. A little bit younger. from Tsukuba University, Japan. But before that, I would like to greet our professor first. Good morning, Professor. Do you have a great day today? How are you today?
I'm fine.
Okay, you're fine. Okay, so how many days have you stayed in Indonesia? 6 days? And this is your last day? Or okay, I hope you enjoy the rest of your stay in our country. And how about our food? Very nice. Okay, you enjoy our food. So to keep on the schedule, please, it is truly an honor for us to have you today. For the presentation, it will be 1 hour long from now until 10 a.m. So please, Professor, the floor is yours.
Thank you very much, Dr. Ang, introducing me. And first of all, I would like to acknowledge Dr. Todd. I'm sorry, I'm not well pronounced it, but thank you very much, Dr. Dodi Hartanto, and thank you very much, Dr. Hardi Yono, and thank you very much all of faculty members, and give me the opportunity to talk on this Ahmad University. It's very much honor. So, okay, now it's coming. No, this is yesterday's seminar. Okay. It's okay? It's coming? Okay. Thank you very much. Yeah, I understand. I don't need this slide. Okay, thank you very much. Today, the university provided me this title, Student Higher Order Thinking Skills in Solving Mathematics Problems. It has broader meaning and includes many things. But I would like to focus on, in relation to the female priority area, this is 7, and priority area 5. University of Tsukuba is a member of female as an affiliate member. So I have been working with the female institutions. Do you know female? Southeast Asia Ministers of Education Organization. So on that context, I have a lot of chance to work together on these issues. And in relation to that, I have a chance to develop the curriculum recommendation book, C-based CCRS for mathematics. It's published 2070. And on that context, we also developed the Indonesian, I also have a chance to collaborate with the government of Indonesia, Indonesian adapted mathematics textbook. And currently, Monday, I just had the new curriculum issues. I just learned, and based on those ideas, I would like to focus on the mathematical thinking as for higher order thinking skills in mathematics. Okay. And I would like to show some references. This is a book of mathematical thinking. I think in Indonesia, there are some universities prefer the textbook, so some of university students know this book. And other references that this is a new recent publication, year 2000, last year, Teaching Multiplication with Lesson Study. And it is from Springer. And other the lesson study book. And from now, I just want to show the related book of the C-based CCR LS. And those two, the newest publication with collaboration of female institutions. Sikkim also collaborated. There's the name of Sikkim. Okay. On the collaboration and developed the exercise book for teacher training, and based on the C-based CCRS mathematics. And based on those content, I would like to talk about student higher order thinking skills in solving mathematics problems. Okay, and this is our website. Actually, what I will talk from now is one of the content from the day after tomorrow. We have the online course, 16 classes, online course, consecutive courses. And the content, what we will talk is that lesson 3 and lesson 4's content. Actually, we already finished that part 1 and part 2 last year. The people who are registered are around 2,800. From the perspective in Indonesia, not so big, because Indonesia has the 4th largest population country in the world. But from the viewpoint of Japan side, it is internationally accepted program. Okay, so I will talk about mathematical thinking as for higher order thinking. Higher order thinking is discussed by Bloom originally, but it's already passed several years, around 50 years already passed. On that means we make clear the meaning from the perspective of mathematical thinking. And this is the C-based CCR-LS developed by the female. And please read. Can you read? This is the content. Mathematical thinking and processes, and mathematical value and attitude and habit for human characters. For developing this document, we collaborate with every country in Southeast Asia. Developing this kind of document is very difficult. Every curriculum specialist represents the country. So not easy to change because they have their own curriculum, of course. So almost all mixtured, okay? Mixtured. On that means some parts are very much close to some countries, okay? On that, and there is mathematical ideas and mathematical ways of thinking and mathematical activities. Those are called a part of mathematical thinking and processes. And the mathematical value, attitude, and the habit of human characters are described by mathematical values, mathematical attitude, and mathematical habit of mind. And when we say broad meaning of mathematical thinking, all those components are involved in. And I have a question. When you discuss mathematics problem solving, do you discuss beautifulness? What is the beautifulness in mathematics? And if you just ask like this, it is very much abstract. However, if we focus on some content, we can easily discuss. And another important point is that content can be acquisited. Through the exercise, we can teach. Okay. On the other hand, reflection, okay, process should be reflected. There are many process of learning or problem solving. After the problem solving, we reflect on about the process, ideas, and ways of thinking and so on. So for learning mathematical thinking, well, this is narrow mathematical thinking, we may need the opportunity to reflect on the process. Okay? And others are appreciation. Okay? For learning values, attitude, oh, this is beautiful, this is beautiful. No. After the process, reflect on, oh, that idea, such a moment we appreciate. Okay? Okay.
Excuse me, because this is also live on YouTube.
Yes.
Your presentation will be live on the YouTube, and we need you to join the Zoom so that this can be shared.
Okay. Yes. But the small word itself is those are references. And if you put in the C-based CCRLS, you can download free. This is a product, those are product of the CMO institutions. So on that mean, all free, you can download. Okay?
Can I pause for a moment? Can I pause for a moment?
Okay. Oh, what does mean? I don't know. Now it's missing. Thank you very much, Dr. Mamans, help supporting me. Okay, now you can see where, and those resources are written in those books. And please search C-base CCRLS. So CCRLS framework in mathematics. Okay. And what I trying to say is that for only exercise are also problem solving, but only exercise we can, so many students, they can acquire mass of content of mathematics. However, for learning ideas and ways of thinking, we need a reflection, and for learning value and attitude, we may need the appreciation. So such a keyword is a necessary keyword for designing the classroom. And another point is that context. That here, if we provide appropriate context, we can discuss those content at the same time. And the context one is, for example, mathematical modeling. On the other hand, context two is a kind of mathematization, develop mathematics from mathematics. So the question is that, how can we design to develop student mathematical thinking? That's the question. We can easily say, if depending on we provide a good context, we can develop. Maybe, but how? Okay? And first of all, I would like to confirm the contradiction of the curriculum. any mathematics curriculum has contradiction. Okay? For example, multiplication increase the number. Is it correct? No, not always, right? So, at the beginning, multiplication increase the number. However, later, upper grade, if we study the decimal and fraction and so on, not always increase. Okay? And subtract smaller number from large number. Is it correct? No, any number can subtract, right? Okay. So mathematics curriculum, from the student perspective, mathematical curriculum includes a contradiction. Okay? And can we teach from the beginning, any number can subtract? Oh, let's calculate, let's operate, let's subtract 2 minus 5 for the first grade student. Difficult, right? So we cannot avoid the contradiction. That's the difficulty of mathematics. And so many cases, because of mathematics, the abstract knowledge, they say, so many cases we say, it is difficult. But what does it mean, abstract? Abstract here means a contradiction. Mathematics curriculum is the major subject of in mathematical curriculum or mathematics learning is beyond the contradiction, overcoming the contradiction. Okay, so that's one of the view, and such a things are discussed by the proof and refutation. All of math educator knows this book, and he is Hegelian, and in the case of principle of curriculum, Hans Freudenthaler discussed mathematization. But he said, reorganize the experience. Okay, reorganize the experience. We have to reorganize. Okay? Otherwise, we cannot avoid the contradiction. We have to rethink. And in Japanese curriculum, we call this extension and integration. Extend the number, integrate again. It is reorganized. Okay? And then in Indonesian curriculum, I just learned Monday, the Indonesian Bahasa Indonesia is maybe different ways of writing, but I just learned, establish the sequence from preconcept to concept. Okay? But it is not consistent always. Students have to overcome. And the principle positively treat the contradiction. Okay? Contradiction is not negative, positive. Okay, that is Hegelian. It is Hegelian. Hegelian. Okay? Construction is the nature. And then dialectic. Okay? Dialectic is discussed from the ancient Greece. If you are saying it is true, if your conclusion is true, what will happen? This is a paradox. Okay? Paradox is have the format of this quotation. Okay? And in didactics, we call it Socrates method. Where is the Socrates method? In German didactics, it is Socrates method. It is the Maetic method. Okay. Such a word we have been used for explaining the overcoming the contradictions. Anyway, I just want to show you the example. Okay, this is the example in this book, okay, Teaching Multiplication with Lesson Study. And this is the process of learning of multiplication. Any curriculum has similar sequence. Okay, we cannot teach from here. Can we teach from here? Difficult, right? Okay, can we teach from here? Procedure there. Later we learn. So we have to begin from here. But it is limited situation A. What kind of situation it is? Okay, and then please note, multiplication is not the addition, but the binary operation. Multiplication is binary operation. This is the method to get the answer. However, if we say this is multiplication, multiplication is addition. Of course, they use what they learned. But we have to distinguish addition and multiplication. Otherwise, we cannot discuss the story problem. And then, law 2. For example, law 2, there are discussions. For example, Bahasa Indonesia and Japanese. Japanese is 2 multiplied by 3 equal 2 plus 2 plus 2, or 2 multiplied by 3 is 3 plus 3. Bahasa Indonesia and the Japanese, I heard are different. Okay. In the case of Bahasa Indonesia, it means this. And in the case of Bahasa Indonesia, 2 multiplied by 3 is the Bahasa Indonesia, this one. And the Japanese become this one. So such a contradiction. And then, sorry, it cannot see well. Is this repeated addition, or by using the distribution? Without using the distribution, we cannot produce the column method. We have to change the way to use law of multiplication table. We have to develop the procedure for the column method. And then, okay, what is interesting for the column method is that we do not calculate 20 multiplied by 4. In the column, when you calculate on the column, okay, you just say 4 multiplied by 3 and 4 multiplied by 2. Right? We don't say 4 multiplied by 20 because it is column method. Column method use the multiplication table only, based on the base 10 place value system. So many things change. I just want to know the how change. And this is that, as I mentioned, the product become larger than it is. No. Sometimes become smaller. And then, okay, like so on. Okay. There are many problematic. Okay. Can you see this calculation? Is it okay? What is the mistake of this? What is the mistake of this? It is a mistake, right? Two over 5 divided by 3 over 2 multiplied by 1 over 3. Erase 3 at first, then calculate, then get this answer. It is what is wrong? Okay, commutativity is only allowed the case of multiplication and addition. Subtraction and division cannot use the commutativity. Such a thing. This is the background of the field theory, right? We only have two operations. Okay? So such a thing, from here to until there, the number itself extended. Okay? So such a process, we are learning, students are learning. So students usually confuse. Okay? And the way of discussion is that if you are saying it is true, what will happen? This is very much constructivistic question. If you are saying it's true, what will happen? Okay? If your conclusion is true, what will happen? Okay? Then there are various approaches. I just showed the various teaching approaches, exam-oriented, and on the other hand, mathematical activity-oriented. And then there are two types. Must read only true. In the case of exam-oriented, you just check. So true-oriented. On the other hand, mathematics is a subject for overcoming contradiction. Okay? And done by teachers who do not design task and lesson. If we begin to design by ourselves, we recognize the difficulty. We anticipate how students think. Then, if we are saying it's true, what will happen? Such these ways of discussion that exist. And then between these approaches, first approach is injunction. Likely based on the exercise. On the other hand, open approach and problem-solving approach is known. And I call this, because of this discussion, the Hegelian style discussion, dialectic approach, we call. And then, from here to here, we usually recommend the student-centered approach. How can we change? We may need to change, do not design. We may have to design, but what shall we design? Designing task only, change the task to open-ended. Okay? Open approach is try to change the task to open-ended or open. On the other hand, problem-solving approach is design task sequence. I will explain this later. Okay? Open approach usually focus on one problem. On the other hand, problem-solving approach, this is Japanese meaning of problem. On the Japanese meaning of problem-solving approach, we discuss task sequence. Okay? And overcoming contradiction. Okay. And objective-oriented, what kind of objective? Okay. From this injection, even the injection approach, we can discuss student agents in general. Develop the student who will learn math by themselves. If they plan the schedule, how they use the exercise book by themselves, it is already a kind of student agency. They learned how to learn. On the other hand, mathematical thinking and ideas, if we try to enhance or develop thinking and ideas, we may need to provide the good context. It means that good process or reflect on. And then value and attitude is just the same. But need appreciation. And then lastly, critique. We want to develop the student who critique the other's ideas. But critique means very strong word. Okay? But in mathematics, it is normal. And the student do math like mathematician without teachers. And those parts usually focus on a problem or problematic situation. And those parts focus on designing task sequence. Okay? I will explain task sequence. Okay. And for explaining task sequence, we have to have the differences of this task and the next task and the other task, likely the previous discussion of multiplication. We have to have explain what's the difference. We may need some terminology to explain the differences. Otherwise, not easy to design the task. Okay? Anyway, teaching approaches is just approaches we can choose, depending on the context. Okay, so from now I will show you 2 videos. Okay? And on this video, please focus on this. Why a second grade student can say wrong? It is critique. Okay? Please see. Second grade student critique. Okay. This video is very famous video, so some of you already have experience to see. But this school is our affiliate school, our elementary school. What? Okay. the all answers are correct, but the order is different. But 5 students can say wrong. Okay? And if we saw a year ago's video, okay, the same teacher, but they are first grade. Okay? 1 year ago, all students are the same student. Okay, so I will show you this video, next video. Why they can say it's wrong? This card behind the expression and the answer and behind the expression. Can you imagine this activity? This activity is written in the new Indonesian edition of textbook for first grade. Okay, and 2 plus 1, 1 plus 2. Behind of 2 is 1 plus 1, right? Okay, that's the activity. Okay? 2 and 4, 4. So, can you imagine the expression? Okay, that's such a question. Now the question is 4. Behind, what kind of expression is it? 2 plus 2 coming first. Okay, and extend this activity more and more. Okay, extend this activity, ordering the card. So on this, based on this experience, previous slide, student can say wrong because they already learned to produce the pattern by using the order of natural number sequence. So they can say wrong. So Japanese problem solving is usually explained as a guided discovery, previously learned already and used. In that context, they are able to think mathematically. They can solve the problem by using what they already learned. That is Japanese approach. And reflection and appreciation are behind existed. Okay? And this is the same task in Indonesian textbook. Okay? Is this beautiful? How can we change it beautiful? Please do it. Okay? After that, they can arrange like this. So the activity of arrangement change the situation beautiful. Okay? So arrangement of the card, we don't show from the beginning. At the beginning should be like this. And then arrange. So it's beautiful. And this is natural number sequence, and at the same time, one step, increase by one. Such a natural number properties they learn. Okay? Make an order. Make in order. Okay? And this is a manner to learn the beautifulness of natural number sequence. And then, here shall we use it? We can use. There are discussion of comparing. We are comparing the size. Okay? Then, task 2. Here, okay? Composite of decomposite of numbers. This is a base to learn the carrying and borrowing. Make 10 activity. And there is natural number sequence that meaning change little bit. Usually meaning change. One step up, one step up, one step up. Increase, right? But one move. Left hand side decrease. Right hand side increase. One move. So looks beautiful and it includes natural number sequence. However, when we apply, there are the differences. So this is the challenge for students. And reflection and appreciation are necessary. Oh, beautiful. Then let's arrange the block, order of blocks. Such activity. And this is the other thing, line up the card. This is the addition up to 10, subtraction up to 10. And then repeat. Then addition more than 10. And subtraction more than 10. Repeat. And that means they have developed a custom to make an order. Then they can say wrong. Okay? Such a manner. And I'm just talking about the ways of teaching. However, behind deep mathematics is hidden. How do you call this activity? At the university level mathematics, how do you call? It is equivalent class. from the first grade, we can discuss equivalent class through this kind of activity. But we don't teach, this is the equivalent class. No, 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 no. Okay? Just say, oh, beautiful order. Oh, beautiful arrangement. Wow, do you develop it? Okay, natural number sequence be hidden. Okay, such a thing. Okay, but the activity itself, later it's become the equivalent class. Anyway, we have time? I can extend? Now the time, right? Okay. So I can continue. The other example, okay? This is the focus of the discussion is that seeds only as a task or seeds in the task sequence. Very much different. How many solutions? Of course, you can imagine more than 4 approaches we have. Okay? More than 4 approaches. And the discussion is that we can count the area by the unit square, and by using the area formula of rectangle, we can add 2 rectangles. And we can subtract. And the others, if we move, we develop new rectangular. Okay? So there are 4 approaches existed on this task. But how students can find those solutions? By using what they already learned. So we may need to consider task sequence. If we only discuss one problem, we can discuss possibility to discuss the many ideas coming. However, how can we approve my classroom student can discuss those 4 ideas? We have to have the preparation. We have to have the preparation. This is the introduction of the area. It's already discussed this. If we move this part there, it becomes the unit square. That's a discussion already done. And then area formula of rectangle. So they both use and apply here. Of course, not the same. Not the same is a point. So students think, and oh, that idea we can use. Oh, you used the, for example, someone solution. This is the someone solution. Oh, you used this, that his idea or something. Such a discussion. Okay, and others. Okay, next task 4. Okay, this is a textbook sequence. And task 4, which idea can apply for this task? Can we draw the square there? Or area can add, area can subtract? Or can we move this part there? Actually, if we move cut this and move somewhere, we cannot develop large rectangular. So those 2 ideas can generalize. And these ideas are specific idea for this figure, this shape. Okay? So such a discussion. So in mathematics, we seek general idea. So general idea is a strong idea. So we understand that the area can add and area can subtract. Then another point is that who will pose task 4? Teacher can pose, of course. How can we develop the student who will pose the other task? For developing such a student, we have to use the term, for example. Okay? Teacher continuously use for example, students are able to use for example. Okay? Such a manner. If, for example, okay, you learn this. So what do you want to do next? If they have the custom to say, for example, they can produce another example. Okay? The same figure, right? Both of figures are in mathematics in ancient Greece. The name is gnomon. Okay, gnomon. Okay? Both shapes have the same name. Anyway. Okay. So other things. Through the task sequence, we can discuss generality and expandability. For students, we don't use this term. Oh, you can use that idea. Yes. But that idea cannot use. That's only. But through such activities, they learn which idea can applicable or not. Okay, so that is generality and expandability. And the usefulness and the efficiency. Oh, that idea is useful. Okay, area can add, area can subtract. That idea is useful. Such an activity. Okay. And the point is that the repetition of appropriate task sequence develop mathematical thinking, value, and attitude. So repetition is necessary. Repetition means use what already learned. We consider the task sequence. For solving this task, for teaching this task today, how student can try. What is necessary knowledge? Then we open the previous pages. Oh, they already learned this. We can use this. But my student maybe forget that idea. Then we prepare the task. Such activity. Okay. And this is my academic advisor, Professor Noda's theory. He proposed the open approach, and he also proposed posing the problem sequence by student. Okay. So we have been Japanese teachers trying to develop these types of classroom through the repetition of the task sequence. Okay. And today's content can be seen through, if you use this QR code. Okay? And actually, until noon, almost noon, maybe one more hours, until Japan time 3 o'clock. So it means that in Indonesian time, until 1 o'clock, you can, if you would like to see more content, please visit this site within 1 hour until 1 o'clock. Okay? Thank you very much for today.
Again, thank you. Okay, thank you very much for the presentation, Professor Masami Isoda, and also for giving us insight about higher order thinking ability in different perspective from student mathematical thinking. That is very inspiring. To all participants in this room and also on our YouTube channel, if you have any question, please, for participant in this room, please raise your hand. And for the participants on our YouTube channel, you can just write the question on our comment section, and I will read your question. Is there any question? Maybe Prof? Okay.
Good morning. Since I'm very surprised with the student have opportunity to create new problem. I think it's very difficult in Indonesia maybe because in student in high school, student in university, sometimes it's difficult to. We ask to student to create new problem. In Japan, from primary school, student have opportunity to create new problem. I think that is price for us. In my mind, in our experiences, Japan society is good in character. For example, how to mutual helping, one help another. In Indonesia we call gotong royong gitu ya. And I think Japan people character is very good. My question is how to integrate it, character in mathematics education. Maybe Prof can give me example how to integrate it, character building in mathematics education. Thank you.
Thank you very much. It is very much important questions, and I know that Indonesian curriculum enhance human character formation. I learned a lot in the past discussion, and here. Sorry. Go back. On the frame, where is it? This one. Okay. Habit of mathematical habit of mind. This is related to the human character. Yes. And in my understanding, we seek the the discussion is that, first of all, on this discussion, challenge contradiction itself, human character. And another thing is that appreciation means that appreciation of my learned idea or appreciation of others' idea, both included. And in the case of Japanese teaching approach, usually students come to the front and present. And when someone presents the ideas, usually audience, students think which idea is closer to me. And it's already the mindset is in the process of appreciation. And on this document, there are discussion of nature of mathematics. In the nature of mathematics, we quoted the case of the discussion between Descartes, Pascal, and Fermat. They have a chance to exchange their opinion as a mathematician. And Descartes proposed analytic geometry. But indeed, analytic geometry is the strange geometry from the perspective of Pascal. So Pascal critiqued Descartes. And between Pascal and Fermat, there are very much sympathetic communication. They send a letter each other, and Fermat send the solution of the a kind of probability problem, and then Pascal listen to the letter, feedback the letter, which is written Pascal's triangle. By using the Pascal triangle, we discuss the combinations. And he sent back the letter, and on that letter, very much interesting things are written. I'm very happy I can share the idea with you. Your developed idea is the same as me. However, I also developed a strong idea. And from now, I will show it to you. So there are two mindsets written. One is sharing, understanding each other. And for understanding each other, we have to represent. It is a represent means that constructive meaning of represent. Congruous spelled meaning of represent. Represent others' ideas in our mind. Represent. So understanding other means that reconstruct by ourselves. So through such activities, we share and each other's ideas. So such a mindset is one mindset, and the others are competitive. Pascal feels competitive Descartes and Fermat at the same time. So mathematicians' mindset, usually we can see those two mindsets. And that means but it is related to it is reasonable or not. If it is not reasonable, we can say wrong. Such things are deeply related to the human character formation. So what we can say here is that mathematical meaning of human character. Thank you very much. Dr. Aldion, thank you very much.
Thank you very much for the question and also for the answer.
I have other proposal. I still continue. Still there, the question?
Is there any other question? Okay, from Mrs. Penny.
Yeah. Good morning, Sensei. Thank you very much for your presentation. Actually, I really concerned about your framework. Is this CCRS framework make it only for Southeast Asian countries, or it could be applied also in another countries? That is the first question. And the second one is, after this big framework, you have another framework, the small. You explained before about the context 1 and the context 2. After this, Sensei, maybe you can next.
Okay.
That's more context. When you explain, the context 1 is related to the mathematical modeling context, and then the context 2 is related to the mathematization. And what are the difference between those two contexts? I think that's all from me. Thank you very much, Sensei.
Thank you very much. Also very good, nice question. And the CCRS is that reference book for curriculum developer. Every country should develop the curriculum by themselves, of course. And that's the discussion of for developing this document. However, this is the result of learn each other. Okay, learn each other. So this is the result of learn each other. So when we read this document, we may need to consider, in the case of our country, how shall we reform, and so on. Such a discussion. So the usage of this curriculum framework is that not the same as national standard. It is a reference book. And for using that reference book, we developed the teacher training exercise book. And what is for example, the problem of Bahasa Indonesia. Bahasa Indonesia, do you distinguish shape, figure, and play figure? In Bahasa Indonesia. In my understanding, Bahasa Indonesia cannot the same use same term shape and figure, right? Bahasa Indonesia. But if you are, because of you mass educator, so you know fine heel levels. Fine heel level, first level is shape. And second level is figure. And the third level is plain figure. So if we do not have the idea to distinguish shape, to meaning of shape, we cannot teach based on the fine heel theory. So such a discussions are related with the content of the geometry. So shapes, figure, solid. Here plane figure, space figure, and the space and the geometry. So key stage 1 is until 3rd grade, and the key stage 2 is until 6th grade, and the key stage 3 is until 9th grade. So for discussing the another perspective or another language, the cases, it might be useful. For example, we can distinguish shape and figures and solid, and plane figure and space figure. So if it is Bahasa Indonesia, it is only one term, right? So such a discussion we made. So referable for any countries. But that is not, on that means this is not the national curriculum standard. And another thing is the context 1 and context 2. Thank you very much, good question. I didn't mention, I talked here, I will talk later. That means that task sequence. Context 2 is task sequence, such as areas example. Okay? And the context 1 is mathematical modeling, begins from the situation, usually. Thank you.
Okay. Thank you very much for the explanation. Because this is already 10:20 and you are scheduled to go back to your hotel at 10:30.
May I say one thing?
One thing. Yeah.
Actually, we are now developing the online courses, and after that, which one? No, this one. We developed those books, and others are going to come from Sikkim and classes in Bahasa Indonesia and English. And we are now planning to develop the new books, such as difference of shape and figure, such discussions, and workbooks, such a thing we would like to develop. If Ahmad University's professors collaborate, it is very much happy. Thank you very much.
Okay, thank you very much. Because we have very limited time, I think the discussion session is already enough. Please, Professor, you can go back to your seat. And before we close today's event, we are going to have a token of appreciation given by the Mathematics Education Study Program. So please, for Uswatun Hasana MSc to come forward to give the token of appreciation to Professor Masami Isoda. Please, Professor, come forward.
Oh.
And one more, Professor, can you give us any quote or positive messages for our Mathematics Education Study Program? Signed by yourself. Yes, write your name and all. Okay, thank you very much, Professor. Please, everyone, give another big applause for the professor.
Thank you very much. And actually, I talked about the textbook, and that is Indonesian textbook already.
Yes.
Thank you very much.
Okay, again, thank you very much for the amazing presentation by Professor Masami Isoda. And as already been mentioned by the professor, that all the materials and also the books can be downloaded on the website, on SEKIM and on CRCED, right? Okay, you can just go to the website and then download all the material that you need. Okay. I think that's all for the presentation for today and also for the discussion. Thank you everyone for all the attention and your participation today. Let's close today's activities by saying hamdalah together. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.